guys, welcome back to my channel. So today I'm going to discuss the multiplication of radical expression. So we have introduction. It is possible to simplify complicated radicals expression using different properties such as commutative, associative, distributive, and product property of square roots. In multiplication of radicals, we have to consider different cases. So in multiplication of radicals, there is three cases. So today I will going to discuss the three cases of multiplication of radicals. So first we have case number 1. Indices are the same. So if we multiply radicals having the same indices, we multiply index of n square root of x times index of n square root of y is equal index of n square root of x and a y. Then we simplify the radicand if necessary. So as you can see in our formula here, they have the same index. So we have an example. Example is we have a square root of 27 times square root of 3. So we need to multiply the 27 times 3. So if we multiply 27 times 3, we have square root of 81. So the square root of our 81, the square root of 81 is 9. So another example, we have 2 square root of 5 times 2 square root of 3 is equal of 4 square root of 15. So we're just going to add the two numbers. And in the square root, we are going to multiply the number inside the square root. So we have case number 2. Indices are different, but radicand are the same. So our index here is different, but our radicands are the same. Or inside the radical symbol are the same. To find the product of radicals with different indices are the same, radicands we have two. A, transform the radicals to power with a fractional exponent. So we're going to transform the exponent into fractional exponent. So B, we have to multiply the power by applying the law of exponent. So if you remember the law of exponent, in multiplication, we are just going to cross multiply. So we will tackle that one in our example. You will understand more in our example. So we have C, simplify the result as a single radical. So example. We have an example here. We have the 3 index square root of 4 times 4 index square root of 4. So as you remember in our what I've explained earlier, they have different index. And then we are going to transform our into a fractional exponent. So we have 4 raised to or to the power of 1 over 3. This is our fractional exponent. As you can see, were we able to get the number 1? Inside the 4, we have our imaginary 1. So that's why we are going to get the 1 over 3. So our denominator is our index. And we have imaginary 1. That was our numerator. So 4 over or 4 raised to 1 over 3 times 4 raised to 1 over 4. So we're just going to cross multiply. So as you can see here, cross multiply. So 3 times 1, we have 3. Then we're just going to add that one. 1 times 4, we have 4. So that was 7 is equal to 7 all over by, so we have 3 times 4 is 12. So that's why we have 7 over 12. So that's why we have 4 raised to 7 over 12. So as you can see, our index, as what I've said, our denominator will be our index and our numerator is the exponent of our radicand. So as you can see, index of 12 square root of 4 raised to 7. Or if we're going to transform this one, because it is raised to 7, we're just going to multiply 4 by 7. Or we're going to multiply itself. The number 4, we're going to multiply itself by 7. So 4 times 4 times 4 times 4 times 4 times 4. So we have 6,384. So we have now case number 3. So in case number 3, indices and radicands are different. So our index and our radicands are different. They're not the same. As we tackle in the case number 1 and case number 2, the case number 1 was they have the same exponent, and in our case number 2, the same radicands but different index. So in case number 3, both of them are different, the index and the radicands. So to find the product of radicands under this case, we have to transform the radicals to a fractional exponent. So this is what we are going to transform into fractional exponent. B, we need to change the fractional exponent to a similar fraction. C is simplify the result into a single radicals. So we have an example here. So as you can see, our index and our radicand is not the same. So index of 4 square root of 3 times index of 3 square root of 2 is equal to, we're going to transform into a fractional exponent. So as what I've said, there is an imaginary one here. So our index is our denominator. So 3 raised to 1 over 4 times 2 raised to 1 over 3 is equal to, we're just going to cross multiply. So as you can see, 3 raised to 3 times I over 12, because 1 times 3 we have 3. But we're going to multiply both of our denominator, 4 times 3, so we have 12. So 2 raised to 4 over 12, because we're going to multiply 4 times 1, so we have 4, so over 12, because 12 is our 4 times 3. So we're just going to transform again in this we're just going to transform like this. So index of 12 square root of 3 raised to 3 and times 2 raised to 4. So we're going to multiply 3 by itself. So 3 times 3 times 3, we have 27. Then 2 times 2 times 2 times 2 is we have 16. So if we multiply 27 times 16, we have 432. So the index is still the same. So that's all for today. Thank you for watching.